Hello everyone. So far we learned how to write an initial guess for the particular solution, right? So we call that as trial form also. Now I kept saying that when we write that initial guess, we have to be very careful for overlaps between the fundamental set of solutions and the initial guess. But we really didn't see such an example. In this video, we are going to see many examples where we do have overlaps between the fundamental set of solutions and the particular solution guess. So when we have overlap, what are we going to do? That's what we are going to learn in this video. So we call that as case 2 also. Okay, all right, so let's get started. Let me explain that to you from an example. So we are going to do a lot of examples, and this is the easiest first example. Okay, so we have this differential equation. Now let's try to write the initial guess as we normally do. Okay, so to do that, well, first we have to solve this homogeneous version of this differential equation. So this is equal to 0. The auxiliary equation is m square minus 5m plus 6 equal to 0. Now I'm going to do this part very fast because we already learned this lesson. So if you're not familiar with this one, if you're not sure how to do this one, go back and watch these videos because it's very important, right? So let's factor it. So it's m minus 3, m minus 2 is equal to 0. So the fundamental set of solution is e to the 3x, e to the 2x. So I found that very fast. Okay, all right, I wrote the fundamental set of solution based on this. Okay, now let's go to that yp part. So what is our initial guess? Well, here we have a constant time and exponential function. So our guess will be like a constant a times e to the 2x. Okay, now do we have an overlap? Now by overlap, what I mean is, do we have the same thing in the trial form and in the fundamental set of solution? Of course we do, because we have e to the 2x here and we have e to the 2x here. So that's what we call an overlap. Okay, now what can we do if we have an overlap? If you have an overlap, your initial guess is wrong. Now remember always, we cannot ever change the fundamental set of solution. Okay, that's what it is. It is what it is. Okay, so you cannot change that. The only thing you can do is to change your initial guess. All right, the way you change your initial guess is you multiply your initial guess by x until you get rid of any overlap. Now that's the simplest way I can explain that, but when we move on to example 2 and 3, I will show you the places that you have to be very careful when you multiply by x. Okay, so make sure you stay until the end of this video. So what do you do is you write a new guess by multiplying your guess by x. So ax e to the 2x, multiply your guess by x. Now check for overlap. Now I want you to understand e to the 2x and versus x e to the 2x, that's two different things. Totally two different things, totally two different functions, or two linearly independent functions. Okay, so now do we have an overlap between this function new guess and the fundamental set of solution? Well, you might say, of course yes, because still we have e to the 2x, right? Multiplying by x didn't make any difference. Well, it did. Remember, I said e to the 2x and x e to the 2x are two different things. So yes, you have e to the 2x and e to the 2x here, but actually it is not e to the 2x, it's x e to the 2x here. Okay, so two different things. So now we do not have an overlap, because here in the fundamental set you only have isolated d to the 2x, but here you have x e to the 2x, but here we had isolated d to the 2x. Okay, so then we had an overlap, but now we don't have an overlap. So this is the correct guess. Initial guess was wrong. Okay, all right, so let's see more examples. We have to do more examples. Y double prime plus 2y prime plus y is equal to 2 plus e to the negative x. I'm doing the examples in the notes. Okay, all right, now let's write the auxiliary equation. This is m square plus 2m plus 1 is equal to 0. If you factor that, you get m plus 1 square is equal to 0. So I did that fast, and the fundamental set of solutions is based on the roots here. So the root is -1 repeated twice, so e to the negative x, x e to the negative x, right, because of the repeated root -1. That's from section 4.3. Alright, so let's look at what we have here. So our initial guess is, well, we have a constant plus an exponential function, so constant plus e to the negative x, b e to the negative x. Alright, so do we have an overlap? Of course, we have e to the negative x here and we have e to the negative x, so we do have an overlap. This guess is wrong, so change it. Multiply by x. Now here's the important part. Now you don't multiply the whole thing by x. That means you don't multiply everything by x. You only multiply the path that contains an overlap. That means a is an isolated constant, right? Do we have a constant here? Just a constant? No. What we have in the fundamental set is e to the negative x and x e to the negative x. This part here does not have an overlap, right? But this part does, right? This is the part that we have overlap. So you only multiply the part that you have an overlap. Let's call the part that we have overlap as the offended part or the offended party. So here the offended party is b e to the negative x. So your new guess is b plus bx e to the negative x. Only multiply the part that you have an overlap, not the part that has nothing to do with the overlap. Okay, all right, so because of that we didn't multiply a by x. Good. Now again check for overlap. Don't stop here. Now a, no overlap. Do we have overlap here? Yes, x e to the negative x and x e to the negative x. See, we still have an overlap, so still this is wrong. Again multiply by x, a plus another x. This will be bx square e to the negative x. Okay, two different things. Now x e to the negative x and x square e to the negative x, two different things, totally two different things. Okay, so this part here, this guess here, do not have an overlap, so this is the correct guess. Okay, not this, not this, but this is the correct guess. See, so what you do, two things to learn from this example. You multiply by x until you get rid of all the overlaps. Okay, but you might need to multiply. Here we multiply x 2 times, right? We changed our guess 2 times. You might need to do it 3 times, 4 times, who knows, right? Depends on the function. So you might need to multiply by x several times. Keep that in mind. And the other big takeaway is that you have to only multiply the offended party. Okay, so let's see more examples. Let's say we have y double prime plus 9y is equal to 2 sine 3x. I'm gonna do 2 more very important examples. So here the auxiliary equation is, try to pause the video and try to do it. I bet 50% of you will write auxiliary equation wrong. So here the auxiliary equation is m square plus 9. Did you write m square plus 9 m? That's wrong. So here I will do the rest very fast. So here the root will be plus or minus 3i and the fundamental set of solution is sine 3x and cosine 3x because the root is complex. Okay, alpha is 0, beta is 3. Remember we learned that. So this is the fundamental set of solutions. Now our guess is going to be initial guess yp constant times sine 3x. So a sine 3x plus b cosine 3x, right? All right, so now do we have an overlap? Absolutely yes. We have sine 3x here and sine 3x, even cosine 3x, cosine 3x. So both parts are, both parts contains overlap. So we multiply every part by x. So ax sine 3x plus this will be bx cosine 3x, right? Okay, now again check for overlaps. Do we have an overlap? Well, x sine 3x and sine 3x, two different things. Okay, x cosine 3x and cosine 3x, two different things. So we do not have an overlap anymore. So this is the correct guess, not this. All right, the final example. Okay, before I do a final example, let's say an important thing. Let's say we had y double prime plus 9y is equal to 2 sine x. Now then the fundamental set of solution is going to be same because this didn't change. But yp is going to be, our initial guess here is going to be a sin x plus b cosine x. Now what do you think? Do we have an overlap? Now we don't, okay? Sin x and sin 3x, two different things, okay? If you need an overlap, you have to have you need sin 3x here, okay? All right, so final example, a very good one. Y double prime plus 3y prime is equal to 10x plus e to the negative 2x. Pause the video and try to do the whole problem. Try to write the particular solution guess, okay? Try to do that and see where you struggle. Okay, so here the auxiliary equation is m square plus 3m, okay, is equal to 0. So if you take out m times m plus 3, so the root m is equal to 0 and m is equal to negative 3. So the fundamental set of solutions will be e to the 0x and e to the negative 3x. E to the 0x is 1, so 1 here. Okay, so that's done. Now the initial guess for yp is, we have 10x, a linear function, right? So ax plus b and plus e to the negative 2x is a constant times e to the negative 2x. All right. Now do we have an overlap? That's the $1 million question. We do not have e to the negative 3x here. So we do not have an overlap with the exponential part, right? So that part is good. Do we have 1 here? Well, it seems to be like no, but understand this. Here's where things get tricky. 1 is a constant. Do we have a constant here? Well, you could say, well, we have a, b, c, 3 constants. But here the nature of 1 is, it's just an isolated constant, right? 1, just a constant. But here a is actually a times x. So it's not just a constant by itself. Here c is a constant times exponential function. So actually c is not by itself. But b is, right? B is an isolated constant. B is just by itself, right? So b and 1 overlapped. Yes, we have an overlap. Yes, I know 1 and b, someone can argue, well, 1 is 1, b is b. Well, both of them are constants. So we do have an overlap here, okay? So what can we do about this overlap? We multiply by x. Now, remember, b, even though it's an isolated constant, it contained in ax plus b, right? Because we wrote b because we had a linear function here. Otherwise, we wouldn't write b, right? So b belongs to ax plus b. So it is a part of ax plus b. So when you multiply by x, this whole party is the offended party. So this is ax square plus bx plus c e to the negative 2x. C is not offended because that's an exponential function. B is a part of linear function. That is how b came there. Okay, that is how b is there. Okay, so we do not have an overlap with we have an overlap with 1 and b. So we have to multiply b by x, not only b, because it belongs to ax plus b, we have to multiply the whole thing by x. Okay, all right, so this is the special example. Well, now we have to check, do we have an overlap? Now we do not have, right? Ax square bx very different, e to the negative 3x very different. So this is the correct guess. All right, so this last example is a very tricky example, but think about that. All right, so then that's it for this video. I'll catch you in the next video. Thank you very much. Bye bye.